Happy Virtual Tuesday to you. Hope you're doing well here. Gonna go over that homework that you did yesterday a little bit. Make sure you're okay with it for the next part of it today. Get you some more practice on it today. So here are the two key things you need to know. Let's see if you know them from the last lesson. What is the equation for a proportional relationship? Well, it's a very simple equation. It is y equals k times x, okay? Or simply y equals kx. Okay, understood multiplication here between k and x, okay? And y and x could be any particular letters. K is called the constant of proportionality, okay? So the constant of proportionality is k, and if you don't know what k is, but you have a bunch of data values, you can find k by taking y divided by x, okay? And so y over x should be the same k value for all yx in a problem. And then to write the equation, you just need to find k, and then you put the variables in there. All right. So looking at the homework, somebody missed this question here. They give you the equation for p, which is perimeter of a hexagon. It's 6 times the side length. 6s means 6 multiplied, okay, times s. Okay, and they give you the side length being 2, and they simply ask you what the perimeter is. All right, so really what you just need to do is take that 2 and replace the s with it, and so it would be 6 times 2. Okay, when you substitute, it's good habit to put parentheses in just in case there is some confusion with decimal points. Anyhow, 6 times 2 is 12, and make sure you label your answer 12 feet. And that's really all you got to do for this one. All right. This one's a little bit harder. In a certain chemical, the ratio of zinc to copper is 3 to 11. A jar of the chemical contains 363 grams of copper. How many grams of zinc does it contain? Okay. So here, we know the ratio of zinc to copper is 3 to 11. Okay, so we're looking for zinc. How many grams of zinc does it contain? Okay, so we're trying to write an equation to find zinc. If you'd rather use y equals, you can, but I'm going to use z equals here. But your equation that you want to try to create looks like y equals kx, okay? So here we're going to be doing zinc equals some k value times the amount of grams of copper. Okay, so we could use C instead of X if you want. So zinc equals K times C. All right, so zinc to copper is 3 to 11. So remember how we find K. We get K by taking Y divided by X. All right, now here is Y zinc or is Y copper? Well, since we're trying to find zinc, Y is actually going to be zinc. And copper is the one that we know, so that's X. Okay? Or Z and C if you'd rather do it like that. Okay, so K equals Y divided by X, or 3 to 11. Now, you could use your calculator here, but you're probably going to get a crazy decimal. So I'm just going to keep my fraction 3/11ths here. So I'm going to have 3/11ths, that's my K value, and I'm going to be multiplying it by the number of grams of carbon, which is 363. Okay, and here you could use your calculator again. If you want to, remember if you're multiplying a fraction by a whole number, you could put the whole number over 1. You could cancel these diagonally, take 363 divided by 11, or you could multiply straight across, then divide. I don't know what you would prefer to do, but I'm going to cancel here diagonally. 11 goes into 36 3 times, so this is actually 33. And then you have 3 times 33, which is 98. So you would have 99, 3 times 33 is 99, 99 grams of zinc. Okay, so maybe you should write out grams just so it's clear. That's not like G. Okay, and you should probably label it of zinc. Okay, all right, let's do the next problem here. Ooh, the challenge problem. Okay, so it's a baseball player's rookie card problem here. So the card began to increase in value once the player retired. It was worth $6.85 in 1997, which was the year he retired. The value has increased by $2.49 each year since then. And then it says, express the relationship Y in dollars based on X number of years since the player has been in retirement. Okay, is it proportional? What is the value of the card in 2008? All right, so there's a lot of parts to this. This is a tough problem. So let's just kind of think about the problem a little bit. So I made this nice little table here. So when the player retires, how much is the card worth? It's worth $6.85. So how many years after retirement is the time he retires? Goose egg, 0. Okay, 0 years after retirement, the card is worth $6.85. Okay. Now, 1 year after retirement, the card increases in value by $2.49. So what is the value of the card? Well, it's not $2.49 because that's the increase in value. It's going to be $6.85 plus the $2.49. Okay, so that ends up being, let's see, $6.85 plus $2.49 is $9.34. Okay, now the second year after retirement, it's going to increase the same rate. Okay, so it'd be 2. And then the second year after retirement is this plus another $2.49. Okay, and so you get $11.83. Now, to write a relationship for this, okay, you cannot simply do y equals kx here. Because if you go to find the k value, you take this y and divide it by x, it's going to be different than this y divided by this x. Okay, this one's roughly 5, and this one is 9. Okay, so it's not y equals kx. To model this equation, you have to consider the rate that it's increasing at. Okay, so it's $2.49 each year, so that's $2.49 times the number of years. But you also have to add, just think how we determined this first year. We added $6.85 to the value it increased by, okay? So we have to also add the $6.85 in. Okay, so there you go. That would be the equation for it. And is this a proportional relationship? Well, no, because it's not of the form y equals kx, okay? Because of this extra part here, it's not proportional. Okay, not y equals kx, so not proportional. And my font just got really huge. But anyhow, what is the value of the card in 2008? Well, what we have to do to get that is figure out how many years have elapsed since retirement, okay? So 2008 minus 1997, okay, so that would be a total of, I believe that would be 11 years. So 11 years from retirement. So you would calculate that in your calculator by, I mean, you could do it without a calculator, but it takes a little bit of time. 249 times 11 plus 685, and that would give you that value. Okay, so hope that helps you understand that problem a little better. Let's look at this last one here. Yeah, don't worry about that last one too much. It was a tough one, challenge one for you guys. All right, so use this table to write an equation to find the total cost y in dollars based on X sheets of stickers. Okay, so you're probably thinking this is a proportional relationship, and you can prove that it is by taking the y values and dividing them by x and see what, if there is a constant k, constant of proportionality k that goes with this problem. So you take 615 divided by 3, and you take 1435 divided by 7, and you should technically do that for all the values to make sure you get the same k value, but they're kind of cluing you in that it is proportional by the way that they're having you fill in your stuff here. So I got 2.05, so it's $2.05 per sheet of sticker. That would be like the unit rate, actually. to use something that we learned about, before Christmas. So $2.05, $2.05 per sheet of sticker. So to figure out the cost for X amount of sheets, the equation would simply be, now remember this 2.05, that's your K value, since it's the same for all the data points here, okay, all these XYs. So Y is equal to 2.05 X, and there you have it. All right, so that is your equation, and that's a powerful thing. Now you can figure out how much it would cost to get 1,000,000 sheets of stickers, so you can put them all over your locker and your best friend and your neighbor and whatever you want to put them on. Okay, so that's it, guys. Hope you enjoyed the little review there. Hope you have some fun with the next set of questions, and I'll talk to you later. Bye-bye.